Hi, good morning. This is Dr. Nirmaladevi, Assistant Professor, Department of Computer Applications from MITS. I am going to talk about linked list concept in data structure. This is very important concept in the data structure. So I am going to discuss about this. So I am going to discuss about what is introduction, what are the types of linked list, what is the working methodology we are going to use in the linked list, and at last I'm going to discuss about summary of whole session by today, what I discuss. After that, if you have any queries or questions, we can approach. If you look on this picture, we have a chain from first person to last person. So this is like some kind of link. So we have link from one person to another. So general discussions about what is the first person, we can say it is the head of the node. We can say it is the head. And whichever the person is to be in last place, we can say it is the tail person and last person in that list. So this is the way we need to go. That is called the general idea about your linked list. Okay, so before that, what is the definition of a general linked list? A linked list, we can say it is the linear data structure. It means we can store our data into the memory, and the elements, we can say it is the data. The elements, we can say it is the data, and it is not stored in contiguous memory location. Usually what we are going to do means in a sequential manner, we have to store our data in a regular basis with the help of your array concept. Usually we are going to go with your array is your linear data structure. We can store our elements into contiguous memory location. That means that sequentially we can store, but in the linked list, not like that. We can store wherever we free place is to be there we can store our elements. That is the speciality. It will be have a linked list concept. Okay. And another one is it is the second most used data structure after the array. So first we are going to go using for your array concept. We can say it is the linear data structure and it is your contiguous memory location. But when you come for your linked list, this is not your linear. It is not we can store for contiguous. It is storing for your non-contiguous memory location. So that is the main advantage. Okay. So if you look on that, if you go for your linked list, basically we will have some kind of informations about we should know what is list. So list is consist of a sequence of nodes. The node is like if you look on that train picture, each and every compartment we can say it is the node. So the list is contains the sequence of nodes, and each and every node it has a two portions. One is to be value. So whatever the elements we should be have, that value we can store it in nodes. Along with we have a link field, or we can say it as the pointer, or we can say it as the reference place. So it will be help to joining to another node. So whichever is to be there for the next place, that node we can join with the help of a link field. Okay. So this is the way we have to do for your each and every node. When you go for your last node, so that is there in your last place in the list, that node it won't have a link part because the after that there is no node. So we have to make it for a null link. If you see that train, the last compartment we can put it for cross. Cross means there is no joining for the next node. We can put for null link. Okay. So after that, the list may or may not have a header. Sometimes it will have engine or sometimes it not engine, but we can set as the train. Like that, here list also sometimes it will be have header or sometimes it may not have header. So we can say like that also. Okay, if you observe that the concept of, if you before the training you will see head is to be there, the head is to be connecting for the first node. The first node have data items, we can say it is the value, and followed by next field. that next field which helps to join to the next node. So likewise, it will go your wherever we are going to store your data, with the help of your link field, you have to connect from one node to another. Okay. So this is the general idea about your linked list. So after that, what is the main thing? What are the main terminology we are going to use for the linked list? So basically, if you consider as a list means you have a successor will be there. Successor is to be mentioning that what is the next node in the next sequence. So that is called, we can say it is the successor. So all nodes have a successor except your last node. So it does not have successor. Another one is producer. So we can say it as the producer is to be previous node in a sequence. So the first node, when you see for the successor, the last node, it does not have a successor. Likewise, producer, if you see the first node, it does not have a producer. So previous which node is to be there, so that we can connect. Later that, what is the length of the list? So that we can see it as the three main terminology we are going to use in a linked list. What is meant by successor, and what is meant by producer, and what is the length of the list. So based on your number of elements, so we can go for a more number of length that list will have, or it will have very less node means it will have very less elements. So based on the elements, we can say it is the length of the node. Okay. Sometimes the list may be empty also, because there is no elements. If no elements means there is no list, so that list we can say it is the empty list. So like that we can see. If you see that picture, okay, so we have a node is to be there. That node, initial node, we can set as the head is to be pointing to the first node. Okay, so that node I told you, it contains for two portions. One is the first part, it is to be holding your data value, that elements we can store. Another field we can set as the link field. So that field which helps to join to the next node. So likewise, keep on, we can join from one node to another with the help of your reference field. Okay, so if you look on your last field, so we can have the first part is to be elements or data we can store in first part. If you observe your last node, last place, we have to make it the null, because after that there is no node. Okay, so we have to make it for that node, we have to say it is the end of the list of that particular linked list. Okay, so we can say it is the tail node also. Then what is the advantage of the linked list? Why we can go for a linked list compared to your array concept? So this is not required. First one is, this is not required to contiguous. Yes, of course, wherever the free place is to be there in memory, we can store. Either it is the first location or middle of the place or end of the place. That is not, we are not restricting for this particular place only, we need to store this record, not like that. So that is the main advantage. That is, we can say it is not required to contiguously, we can store our data in the memory. Another one is, we can with the help of that, with the help of your linked that representation, you have to connect for all the datas. So that is another advantage. The node can reside anywhere, it will be there anywhere in the memory, and we can link it together to make a list. After, we have to form one kind of things. Okay, so this is called, we can say it as the optimized utilization of space. So through that we can store it in data in wherever the free place is to be there. No, through that we have to get for the optimized utilization. So we are going to use all free memory space with the help of storing all the values. So that is the additional advantage the linked list will have. No need to empty node to be present in the linked list. Yes, if the list is don't have any node means we can remove the list from the memory. So that is also we can do. That is called, we can no need to empty node to be present in the linked list. We can remove it. Okay. Next one is, we can store your primitive types and objects, all type of data we can store in the linked list concept. So these are the main advantages which is going to discuss about your linked list. That's why we are going to going for your linked list concept. Later, okay, later what are the types are available, which is to be more important. Are they using for your regular life? So that kind of things we can discuss now. So basically, your list is contains for four different kind of types. Singly linked list, another one is doubly linked list, circular linked list. At last, we have to say it as the circular doubly linked list. Okay. Today class, I'm going to talk about singly linked list. So what is meant by singly linked list? We can say it is the alternatively we can say SLL, single linked list, or we can say it is the singly linked list. Okay. So the name itself, you just notify that singly means a single connection. So you have to connect from a one node to another. That is called, we can say it as the single linked list. So you have to each node we have to contains the value, and it is the link field. With the help of that link field, you have to connect your successor. That is the working methodology which will be used in your singly linked list. Okay. So of course I told you your last node, it does not have a successor because that is the last node in your list. So you don't have your successor. As well as the header is to be pointing to the first node. Always, whatever the list is to be there, we have a header and we have a chain. That two things will be there. So the header is always to be pointing to your first node in the list. So with the help of a header, you have to connect whichever node is to be there in your memory, we can connect it through that head node. Okay. So or it contains the null link if the list is to be empty. If there is no node will be available in your memory means the head contains the empty. So it means that there is no data in the that particular list. Only empty data will be available. Okay. So this is the way we are going to represent in a single linked list. If you see that first picture, we can say it is the node. That node contains two parts. The first part is to be holding your value. Whichever data you're going to have, that value we can store it in your node first place. If you go with your second part, that is the link part, that link part which it will be helpful to connecting for a next node. So this is the general pictorial representation about the node. If you look on here, how we can go for a single link list. If you observe this picture, so we can start. So whatever the work we can start, we have to start with the help of a start menu. So that is called, we can say it is the start, we can say it is the head node. The head node is to be connecting for the first node in the list. So here 2 is your first node. That elements, 2 is an elements, values we can see. Then what is a 100? What is the value? That 100 is to be a address of the next node. This you can imagine. That second part, it is we can use for the link or reference, we can say what it is generally by default it should be there means in that particular place your second node where it is to be locating in the memory. That the location address we are going to give in the first node place link field. So that is the meaning of that 100 value. So likewise, if you go for your next node, you will have an element called a 3 and we can connect with your 104 memory location. So likewise, we can connect from one node to another with the help of your reference addresses. Okay. So this is a general idea about your singly linked list. So with the help of that, what we are going to do in the single list, we can traverse a linked list. For example, I want to search some elements is to be there in a list or it is not there. So that kind of operations we can do with the help of your linked list. Main thing is we have to traverse it. Traversing is to be very easy if you go for your linked list. So traversing means just for visiting each node throughout the end of the place. That is called, we can say it as the traversing. Okay. So how to traversal? Usually we have to traversal from a forward direction and a backward direction. Okay. But when you go for your single linked list, definitely you have to go for your forward direction only, not for the backward. So backward is we can go for your doubly linked list. In singly linked list, we have a only one connection will be there, that should be in forward direction. Okay. So the same thing, whatever we have to visit your element. If you want to print means you can print. After printing your data, you have to visit your next node. You have to find out whether whatever you are going to searching element is to be there in your list, that you can print. So likewise, we have to do for your traversing. Okay. So if you observe that picture, the head is to be holding your first node. It will be have 23. It is a value. That node is to be linking to the another node. It will holding for 34. For example, I want to search an element 34 is to be there in a list. So likewise, I want to search. For that, I'm going to using a concept called a traversal. So through the traversal, I have to search. But the thing is, you have to visit from first node to last node. So that is also it is a mandatory. If your data is to be in middle of the place, no issue. You can visit up to that node. Or else you didn't find your node till last means you have to visit. After visiting for all the node, you have to see that particular element is not to be there in your list. So likewise, we have to tell some kind of informations to the user. Okay, so that is called we can say the traversing a linked list. Okay, what are the operations we can do? With the help of that, what are the operations we can do? So we have do for your different kind of operations. That is, you have to insert for any element of basically what we have to do in the single list is you have to insert any element, or we can remove an element. Okay, or we can traverse, or you can find some elements into the linked list. Okay, so with the help of operations we can do. If you look on that, you have to insertion is to be, it will have a three different kind of places we can insert. You have to insert an element in beginning of the list, or you have to go for your last place, that is you have to append the element into the last place, or you have to insert in middle of the any places based on that some index, you have to insert that element. Likewise, deletions also it will be done. So I want to remove some element in the first place, or it may be in last place, or it may be middle of the place. So that kind of operations we have to do. Along with you have to do for your reverse, for doing for all the elements, searching some data from the list. So these kind of operations we can do. Okay. So these are the operations we are going to discuss by now. Okay, first I am going to discuss about how to insert an element into the list. I told you it will have three different kind of types. At the beginning, at the end, you are going to append your list, and as you have to insert your specific position. Okay, so these are the three different kind of ways we have to insert an element into list. Okay, so first concept is insertion at beginning. Okay, so I have a list, I have a node. If you observe that the old link we can say it is the old list, it will be there. That list contains two nodes. Now I want to insert one new node called as a new node. The name called as we can new node. That new node we can say it is the pointer. Okay, so how to insert an element, how to insert a new node into existing list. Okay, so this is the way we need to redirect. First you have to make it your whatever node we can say, that node we have to say it is the new node. Okay, so now what you are going to do, we have to make it, it is a pointer. That new node we can make it a pointer. That pointer initially it will be holding the first place your value that you can capture. But in to go for your second part, you have to make it your pointer next is equal to head. It means that previously your head is to be pointing the first node. Now you have to reconnect. Now you have to reconnect. Now you want to connect that new node into your existing list. Okay, so what you have to do, you have to do two simple steps. The first step is to be your new node, that next is to be pointing to the existing head. Okay, so later what you have to do, you have to make it now Your head is to be pointing the new node. That is called head is equal to pointer. So if you make this connections, if you make this simple steps, automatically your no new node is to be adding into the first place of your list. That is called, we can say it is the insertion at the beginning. Okay. Now I am going to discuss about insertion at end. Okay, so I have existing two nodes will be there. Now I want to insert one more node. That one more node should be in last position, last node, that is tail place. So how I want to add? Okay, so if you look on that, so existing node, already existing last node, we have to make it a temporary node. Okay, so that node you have to assign a name called as temporary node. Now what you are going to do, you have to create a new node. After creating that, you have to assign your value. So you have to make it your null pointer, make it for the null statement. You have to put a cross mark. Okay, so whatever node we are going to give, we have to give in the name called as pointer. Now how to connect this? How we have to make it two steps here. First step, go to your temporary node. Temporary node link field, previously it was there for null. Now we can remove that null statement. Instead of that, we have to connect with your new node. That is the first statement. Your temporary node next field, you have to make it for the new node. So your new node name is to be pointer, PTR. After what you are going to do, if you give that connections means automatically your new node is to be appending your last place. Later what you have to do, you have to go for your, make it your pointer reference path is to be null. That is called pointer implies next is equal to null. So you have to make it your last node of your list, last place, last path, you have a null statement. That is called, we have to insert an element at the end of the place. What is the next concept? So I told you how to insert an element of the beginning of the place and the end of the place. Now I am going to discuss about how we need to insert an element in anywhere, middle of the place or after the first node or before the last node. How I want to insert, we can say it as the position. So we need to find the index where I want to insert. Okay, so if you look on that, if you look on that, I have a new node. So we can make it for your two connections. That is, we have to connect for your successor node also, I need to do, and a producer node also I have to do. What I am going to do? Okay, so we have to make it where I want to make it, where I want to insert. Before node, you have to consider as to be temp node. What is, we have to your existing node. After that only I want to insert. So that node you have to make it a temporary name called as temp node. Okay, so what we have to do means, first thing, you have to make your new node pointer. I told you new node we can say it as the pointer. So pointer dot next. So you have to make it pointer arrow next. I am going to connect. What I should connect? Already your temp node is to be pointing to the next node. That you have to disconnect first. That is the first line it is showing. Pointer dot next is equal to temp node next. So we are going to disconnecting a old nick. So one connection is to be over. Next, what you are going to do, now you have to include, now you have to insert your new node in that proper place. That is your second step. Temp dot next is equal to pointer. So if you give these two steps, automatically your new node is to be append, your new node is to be join that particular place. This is called, we can say it as the insertion at position. Next one is, so up to that we discussed how to insert an element with the three different kind of techniques. Now I'm going to discuss about how to delete an element. This is also have three different kind of methods only. I want to delete in first node, I want to delete last node, and in the middle of the places also I can able to delete. Okay, so now I am going to discuss about how to delete a node at the first place. Okay, so I have three nodes. That list is contains the three nodes. The first node is to be holding for the head. Okay, so whatever you are going to deleting your node, that you have to make it a name called as pointer, ptr. Okay, now I want to make it. So what you are going to do, you have to make it your initially your ptr is to be holding your head. Okay, the head is to be holding your pointer. Now we can remove it. How to remove? Your pointer dot next, you have to make it your head. Head is to be pointing to the next node, that is second node of your list, that you can do. So head is equal to pointer implies next. It means that previously your head is to be holding your first node, that we can disconnect now, that is called old link. Okay, so you have to make a connection. Head is equal to pointer implies next, so automatically now the head is to be pointing your next node. After connecting that, you have to make a free variable. It called as, you have to delete a particular node. That is a term called free. Okay, so it is a function. So it is used to geallocate your data from your memory location. So that way we have to do. First thing, you have to connect the head to the next node. After only you have to remove it. Okay, so that is called deletion a node at the first place. So if you look on your this slide, it is to be the same concept only, but you are going to deleting a node in the last place. That is we have to see. Okay, what we have to do. So how to delete? First thing, you have to do two things. Whatever you are going to deleting your node, that you have to take it for the pointer. Deletion node should be a pointer. And the previous, your predecessor node, we have to make it for the pointer one, because that node hereafter it is the last node, so that we have to do. So what I am going to do, you have to make it your pointer one dot next. It means that your deletion node before the node, you have to make it your reference pointer as to be null. That you have to do. If you make it null, means automatically your existing node, automatically it will delete. Automatically it will disconnect from your list. That you have to do. So that is the thing we have to do. Pointer one dot next is equal to null. After making that, automatically your last node is to be disconnected. So you have to go for your free pointer. Free of pointer means, so you have to delete your already existing node for the list, that is last node of your list. That is called, we have to say it is the deletion at the end. So this is a tricky. So the for insertion at beginning place, insertion at the end, it is to be easy somewhat compared to your position place. The same thing, how we need to insert an element at the position, the same thing only deletion also we have to do. So how to delete an element or any particular place, anywhere. That is not your first node and that is not your last node. In between, you have to delete intermediate node, whatever after your first node or before your last node, you can delete, or in between center of the node also we can able to delete. Okay. So how to delete? So position, that you have to find out. So first of all, we should know which node I want to delete. That you have to make it for the pointer. You have to name it a node called as a pointer. So before your producer node, you have to make it a pointer one. Okay, so that two things basically we should do. So now what you are going to do, you have to remove your old link. Okay, so how to remove? Your pointer one dot next is equal to pointer dot next. It means that you have to disconnect your in between node and you have to give a new link to the next node. So that is the meaning of that. Pointer one dot next, whatever is to be holding, previously it is holding your pointer. Now what you are going to do, you have to connect your next node of your pointer. That you should do. That is called pointer dot next is equal to pointer dot next. After you have to make it for new connection, you have to remove your pointer node. So that is the simple two steps we have to do. That is called, we can say it as the deletion at position. Two things. You have to omit your old link and you have to make it for the new link. That two things we have to do. Okay, so if you observe that on real-time example, your first node is to be holding a 2 value, next node is to be holding 3, later 10 and 7. So which node I want to delete? I want to delete for a third node. Okay, so how to delete? You have to disconnect. You have to disconnect your whatever previously that pointer 1 is to be holding for the values for your 104 memory location, that you can remove it. Instead, what you are going to do, you have to connect your next node address. What is your next node address? I have 108 location. That location you have to provide your 100 node is to be 100 is to be the memory location. There you have a node called as 3 value, no, there you have to fill. So likewise you have to delete your element at your any place or any index. So at last we came to conclusion. So what are all points we have to discuss by today? So we have to discuss about what is linked list. So it is a very important concept in your data structure. We have to say it is the linear data structure. Usually array and linked list we can say it is the linear. If you go for a non-linear, we can go for a graphs, trees, all the things we can say it is the non-linear data structure. Okay, so another important difference between your array and your linked list. If you go for an array means it is a contiguous memory location. We have to store elements from starting to sequentially we have to store our elements. But if you go for your linked list concept, it is not like that. Wherever the place, empty places to be there in your memory, we can store our elements. So through that link field, we have to make connections. That is where another thing we discussed by today. After that, list means collection of nodes. It will consist of more number of nodes will be there. So that is called a list we have discussed. Each node, each node it will have two portions. One portion we have to store our elements or we can say it is the value, and another portions we have to say it is the link portion or reference to the next node. Okay, so these are the points we discussed by today's session. So especially we have to discuss for single link concept. So I told you we have different types of linked list concept was available. I discussed only for the linked list. In forthcoming sessions, I'm going to discuss about a doubly linked list and a circular linked list. Okay. So if you have any queries regarding a single linked list concept, kindly post with the help of this Google form. Thank you.